Hello, learners.
Welcome back to Wizartist. In today's Vedic math series, we're going to be studying the fourth chapter, that is multiplication by certain numbers. These certain numbers are 11, 111, digits of 9, that is 9, 99, 999. Then for numbers from 12 to 19, those are 12, 13, 14, 15, 16, 17, 18, and 19. Starting off with the first subtopic, that is multiplication by 11. This is done using Nicolum. Now, I'm not going to be going in deep how is Nicolum used here, but the general formula that we use is xy into 11, where x is the tens place and y is the ones place, is equal to x plus y, y. What this means is that if we're multiplying a two-digit number by 11, we're most likely to get a three-digit or a four-digit number. Let's just consider a three-digit answer this time. So, okay, what I'm trying to say here is that when you get a three-digit number, the ones place is going to be same as the ones place of the number we're multiplying. And the hundredths place is going to be same as the tenths place of the number that we're multiplying. Now, this tenths place may vary if we have any carry forward, but let's not look at that now. And the middle, that is the tenths digit over here for the answer, is going to be equal to the sum of the ones and the tens digit of the number that we're multiplying, that is xy over here. Now, if you're not able to understand using this general formula, let's basically have a look at an example. The example over here is 26 into 11. 26 is going to be divided into three parts, as we have seen. The three parts is x plus y, and y, right? Now, first we're going to write down x. X in this case is 2, and y in this case is 6. So we're going to write down x as it is over here, that is 2. Then we're going to write in the ones place y as it is, that is 6 over here. And what's going to come in the middle place? That's right, x plus y, that is 2 plus 6. That is 8. Now, if you find the whole concept of x and y confusing, just ignore that. Just simply look at the digits of the number as they are in the numerical values. So again, let's repeat. For 26, right, we're going to first put the 6th place over here. I mean, the ones digit over here in the ones digit of the answer, the tens digit in the third position of the answer, and then the addition of these two. So when you add 2 plus 6, you get 8 over here. Thus, the final answer is 286. You're basically going to combine them all, and then you're going to get the final answer. Let's have a look at another example to understand this better, along with the concept of carry forward. Here we have 38 into 11. As we know, we're going to divide it into three positions. The first position is going to be filled with the tens digit as it is, that is 3. The ones digit, the ones place, that is over here, is going to be filled with the ones place of the number as it is. And in the middle is going to come 3 plus 8, right? That is 11. Now, are we going to write it 3118 as we saw in the previous example? Well, no, this is going to be wrong because over here we're just going to be considering the ones digit for this, right? What happens to the other one? That is this one. Basically, it gets carried forwarded to the next number. The next number in this case is 3. So when you add 3 plus 1, you get 4. That's what we're going to write in the final answer. Then the number 1 from the middle part, the ones digit is 1. That is going to come down as it is. And then 8 is going to remain unchanged. Right. So basically, if what happens over here is that if you have a two-digit number coming in the middle part, you're going to keep the ones digit as it is and carry forward the tens part to the next number, that was 3 in this case. Thus, the final answer that you're going to get is 418, not 3,118. This overall is going to be wrong. You have to do the carry forward part, okay?
Now let's move on to our next subtopic, that is multiplication by triple one, that is 111.
So it's similar to what you did with 11, but you get an addition of another place with the same rule, x plus y. over here. As you can see in the general formula, xy, again, x is the tens place, y is the ones place, multiplied by 111 is equal to x, that is tens place. At the last, we're going to place x, that is the tens place. At the last, we're going to be placing y, that is the ones place. And in the middle, we're going to have two places, both of which having the same value, x plus y and x plus y. Understanding it better with an example, because the whole concept of xy kind of gets confusing to learners. So when you have a number 26, you're going to separate the answer into 4 places, right? So for 11, you were doing it for 3 places. Over here, you're going to be doing it for 4 places. Now, according to the rule, here we're going to be placing the number as it is, 2. And over here, we're going to be placing again the number as it is, 6. What happens for the middle parts? Well, we're going to add the digits, 2 plus 6, that is 8, 2 plus 6, that is 8, for both of the places, right? So that's it. Over here, we're not going to be doing any carry forward because that is not required. And thus, the final answer will be 2,886. Let's have a look at another example to make the concept more clear. We have a 3-digit number this time, 381 into 111. Now, for a 3-digit number, the rule varies slightly. You're going to have 5 places this time instead of 4 places, right? In the first place, you're going to obviously place the number as it is, 3, and in the ones place, you're going to be placing the number 1 as it is, right? So this 3 comes over here, and this one comes over here as it is. Now, what will happen with the middle 8? Let's see. Now, starting off slowly, we're going to find out what we're going to do over here. Are we going to, because usually we would add the 2 numbers that we have, right? But over here we have 3 numbers. Are we going to add all of them? Well, no. We're going to be adding the first 2 numbers, that is 3 and 8 over here. And the answer for 3 plus 8 is 11. In the middle, we're going to be adding all the 3 numbers, 3 plus 8 plus 1, that is 12, right? And then over here, for the second last one, we're going to be adding the last 2 digits. That is 8 plus 1, 9. Right. To recap, the first digit is as it is, the last digit as it is. For the middle ones, first one is going to be the sum of the first 2. The second last is going to be the sum of the last 2. And the middlemost is going to be the sum of all of the digits, right? Over here, we're now going to be writing it down as 3111291, which is approx 31 lakh 11,291. Well, that is going to be wrong again, because the middle terms over here, we're going to be considering only the ones digit. That is, for the final answer, we're going to be only taking 9, 2, and 1. Right. So what happens to the remaining ones? This one and this one. Well, simple logic, we're going to be carrying it ahead. Plus 1, and that is going to be 2. Right, so we have 1 as it is over here. We have our 9 as it is over here. We have our 2. When we carry forward this one over here, we get that, again, a 2. Then we're going to have another carry forward for this one, 2, 3. So 3 plus 1 is 4, right? So this is what we're going to get as our answer. Therefore, our final answer is going to be 1 as it is, 9 as it is over here, 2 as it is, then 1 plus 1, that is 2, and then 3 plus 1, that is 4.
42,291
is going to be the final product for the 2 numbers. Moving on to our next subtopic, by digits of 9. Now, first, let me clarify what by digits of 9 mean. Digit of 9 basically means 9, double 9, triple 9, 4 times 9, etc. Right? So the series goes on. This is what it basically means, right? So it's 9, 99, 999, 9,999, and so on. And this, as well, we have 3 different types. Equal digits of 9, more digits of 9, and less digits of 9. I'm going to be explaining what each of these mean as we move further into the subtopic. Starting off with by equal digits of 9. What equal digits of 9 basically means is that if we have a ones what equal digits of 9 means that the number of digits the number has, the same number of digits the 9 should have. Suppose I have a single digit number x, then it should be multiplied by 9. So this has one digit and this has one digit. If I have a double digit number that is xy, then it should be multiplied by two digits of 9, that is 99. So this has two digits and this also has two digits. If I'm multiplying it xy by xy and z, that is a three-digit number, then guess what I will be multiplying it if I have to apply equal digits of 9 rule? Well, you are right, 999, because this also has equal digit, that is 3 and 3. We're going to delve into this further with the help of examples. Now let's have a look at the rule. Basically, the rule states us to break the answer in two parts, similarly how we did it for 11, wherein we broke the answer into three parts. Over here, you will break the answer in two parts. The first part is made by subtracting 1 from the number, and the second part is made by the nichelum of the number. So we have these two parts, right? One and two. Now the first part, that is this part, is basically the number minus 1. And the second part, that is this part, is the nichelum of the number. We learned about nichelum in a previous video, that is Basics of Vedic Math, which you can check out if you haven't. But what nichelum basically means is all from 9, last from 10. But you'll understand it better if you simply go and watch that video first. But don't worry, I'll be explaining that in short once again once you have a look at the examples. Right, so by equal digits of 9, the answer has to be broken into two parts. First part is the number minus 1, and the second part is the nichelum of the number. Wow, that seems simple, right? So let's move on with an example. We have 35 into 99. Now, look, 35 has two digits. So does 99. So now they are equal digits of 9, right? If I were to do 35 into 9, the rule wouldn't apply. Neither would it if I had done 35 into 999, right? Because this has two digits and this has one. These aren't equal, right? And same over here, there is two digits, and over here there are three, and again, these aren't equal. We need these digits to be equal to apply the equal digits of 9 rule. Right? So the equal digits of 9 rule does apply over here, right? Because the digits are equal, both have two digits. So we're going to separate the answer into two parts. The first part is 35 minus 1, that is 34. Simple. The second part is basically the nichelum of 35. Let's take out the nichelum of 35. Nichelum means all from 9, last from 10. So all from 9, last from 10. First, we're going to have a look at the last digit. So the last digit, that is 5, is going to be subtracted from 10, and the remaining digits, that is only 3 over here, because there is no other digits ahead, are there? No. So 3 is going to be subtracted from 9. 9 minus 3, 6. 10 minus 5, 5. So the nichelum that we get is 65. We're going to place that down as it is. Thus, the answer is going to be made by combining these two values, 3, 4, 6, 5. Let's have a look at another example with this time with three digits. We have 349, three digits, 999, three digits again. That is equal, and hence we can apply equal digits of 9 rule. Let's separate the answer into two different parts. The first part is subtracting it. That is 349 minus 1. That is 348. Simple. The next part is nichelum of 349. Now, again, all from 9, last from 10. The last over here is 9. So 10 minus 9. And the rest are 3 and 4. So 3, 9 minus 3, and 9 minus 4. Right? That's what we're going to be doing. Right? The last digit is going to be subtracted from 10. That is equal to 1. Then 9 minus 4, 5. 9 minus 3, 6. 651, which we're going to be placing as it is. Then we're going to be combining here again. That is 3,48,651. Let's move on to the next subtopic, that is by more digits of 9. Here, more digit of 9 means that the number of 9s is going to be more than the number that we have. Suppose if I have to multiply 12, I can multiply it by a three-digit number of 3 digits of 9. What I mean by that is that 12 has 2 digits, right? So whatever number of 9 should be, it should be greater than 2. So it can be 3 digits of 9, or it can be 4 digits of 9, or so on. Let's have a look at the rule. This time, we are going to break the answer into 3 parts. The first part is made by subtracting 1 from the number, and the last part is made of the nickel of the number, which is the same as the last rule. The only difference is the middle part, which is filled by the required number of 9. Now, what does that mean? Let's understand. First, let's see what appears in the 3 parts. In the first part, we have number minus 1. In the last part, we have nickel of the number. And in the middle part, required number of 9. Let's have an example to understand what required number of 9 mean and also understand the concept better. So here we have 115 into 4 times 9. 115 has 3 digits, not 4 times 9 is 4 digits. So the number of 9 is more, right? So therefore we can apply the more digits of 9 rule, right? So first of all, we're going to divide the answer into 3 parts. The first part is made of the number subtracted 1. That is 115 minus 1, 114. The last part is going to be made from the nickel of the number, that is 115's nickel, which is going to be simply 885. To recap it again for you, it's going to be the last digit minus 10, that is 5, and the rest digits minus 9, that is 8 in the both case. 9 minus 1, that is 8 and 8.
Therefore, we write 885 for the last place.
Now, the middle is supposed to be the required number of 9s. To determine the number of 9s that we require, we're first going to have a look at the total digits in the question or in the problem. So we have 1, 2, 3, 4, 5, 6, 7. That is, the total digits are 7. While on the other hand, in the answer that we have currently got, we have 1, 2, 3, 4, 5, and 6 number of digits. Therefore, we need 1 9. How? We basically need to make the total digits of the question and the total digits of the answer to be equal. These are currently not equal, right? 7 is not equal to 6. How do you make it equal? You basically add 1 to 6 to make it equal, right? This is how it works. Now, we are going to add 1 9. When we add a 9 over here, then the total digit will become 7, right? 1, 2, 3, 4, 5, 6, 7. That's it. So the total digits in the question and in the answer will become equal. Therefore, it's going to be the correct answer. So we're going to add a single 9, 1 9, because that's what we require. And now if we count 1, 2, 3, 4, 5, 6, 7, it's equal to the question. Therefore, the final answer is 11,49,885. Another example can be 67 into 4 times 9. 67 has 2 digits and 4 times 9 have 4 digits, which is more. So again, we can apply the more digits of 9 rule. Starting off with the first place, that is 67 minus 1, that is 66. The last part is going to be the nickel of 67, which is going to be 33. Here's the process once again. 10 minus 7, which is 3, 9 minus 6, which is 3, therefore we get the answer as 33. The middle part is going to be the required number of 9s. Let's count the total digits over here. 1, 2, 3, 4, 5, 6. So the total digits in the question, in the problem that we have is 6. On the other hand, in the answer that we have received so far, 1, 2, 3, 4, it's 4. So how do you make 4 into 6? You basically add 2, right? Because 4 plus 2 is equals to 6. So the number of 9s is going to be 2. Another simple thing that you can apply to find out how many 9s are required is subtracting these two numbers. So the number that you have over here minus the number
Over here.
6 minus 4, which is equal to 2, right? So 2 9s are required, which we're going to fill in, and the answer is going to be 6,69,933. Let's move on to the next concept, that is by less digits of 9. What does less digits of 9 mean? It basically means that if I'm multiplying x, y, z, it should be multiplied by digits of 9 that is lesser than 3, because x, y, z has 3 digits, right? So this has to be lesser than that. So it can be 2 or 1. So it's going to be 9 or 99, as long as it's lesser, right? So suppose again, if I have 1234, I can multiply it by 9 or 99 or 999 because that is going to be smaller than the number that we have over here, that is 3, right? So 1234 has 4 digits. On the other hand, 999 has 3 digits, which is lesser than the number of digits this number has, right? What it basically means that the number of digits the number has, the number of digits of 9 should be lesser than that. The rule for this is slightly different. If you're multiplying by 9, it's going to be the number multiplied by 10 minus 1. If you're multiplying by 99, it's going to be the number into 100 minus 1. If it's going to be by 999, it's going to be the number multiplied by 1000 minus 1. Right, so how does this work? First of all, this means the symbol multiplication, not the variable x. Next, 10 minus 1 is 9, 100 minus 1 is 99, and 1000 minus 1 is 999. So this basically works in the same way, except it's written differently, which makes it simpler to calculate, because multiplying by 10, 100, or 1000 is easier than multiplying directly with 9, 99, or 999. Let's have this example, 12 into 9. Here 12 has 2 digits and 9 has 1 digit. 2 is greater than 1. That's basic math. So that means that the digits of 9 is lesser than the number. Therefore, we can apply the rule by less digits of 9. Over here, the number that we have is 9, and the rule for that is number into 10 minus 1. The number that we have is 12 multiplied by 10 minus 1. Now, what does 12 into 10 minus 1 mean? If you are in higher grade, you know how to solve this, but if you haven't learned that yet, let me explain it. So what this means is you're going to be multiplying 12 by 10, and then you're going to be multiplying 12 by minus 1, right? So multiplying 12 by 10 is 120, and then multiplying 12 by minus 1 is minus 12, right? So this is what we're going to be getting. As you can see over here, it is 120 minus 12. Right, so 12 into 10, that is 120. 12 into minus 1, that is minus 12. When you subtract that, basic math, you're going to get 108. Next example is 134 into 99. 134 has 3 digits. 99 has 2. 134 has more digits. On the other hand, 99 has less digits. So we're going to be using less digits of 9 rule. The rule for 99 is number into 100 minus 1. That is 134 into 100 minus 1. How this works is we're going to be first multiplying it by 100. So 134 into 100 is basically 134, and we're going to be adding 2 zeros behind. That's basic math. Right. That is going to be 13,400. Then we're going to be multiplying this by minus 1. So minus 134. Got it. So now we're going to be subtracting this. Now, 120 minus 12 was a simple subtraction, which you could have done mentally. But this, on the other hand, is a slightly lengthier subtraction. So I'm going to be revising how we can do this using Nicolum. In Nicolum, we go in this way, right? So first, we're going to be putting 1 as it is, 3 as it is, 4 minus 1, that is 3 as it is. Now, over here, the upper number is lesser than 3, so we're going to be adding 0 plus Nicolum of 3. I'm sorry, this is supposed to be 3. Nicolum of 3. Nicolum of 3 is basically 7. So 0 plus 7, that is 7. And then we're going to be adding the minus 1 over here. That is very important. Moving on next, as 0 is smaller than 4, we're going to be following the Nicolum subtraction rule. 0 plus Nicolum of 4. Nicolum of 4 is 6. 0 plus 6 is 6. And let us not forget to put the minus 1 down. Right? I kind of went a bit fast with this because I have already explained this in the previous video of subtraction, which you can go check out if you didn't understand it now. We're going to be doing the final calculations with the minus ones wherever they were placed. It's going to become 13,266. Therefore, the final answer for this is going to be 13266. All right, moving on to the next example. We have 1567 into 999. This has 4 digits, this has 3 digits. The number of digits in the nines is lesser. Therefore, we can use the less digits of 9 rule over here. The rule for 999 is multiplying the number by 1000 minus 1, because 1000 minus 1 essentially equals to 999, right? We're just going to be first multiplying this number by 1000 and then minus multiplied by 1. So 1567 into 1000, we're going to be adding 3 zeros. Then minus 1 is the same number, just we're going to be adding the minus sign ahead. Subtracting this, we are going to be getting 1565433. I'm not going to be going again to the Nicolam subtraction steps, but this is the final answer. Moving on to the next concept, multiplying with numbers 12 to 19. Now, this is such an amazing trick because it makes the multiplication so much simpler. It's a bit complicated to understand initially, but once you get the trick, it becomes so simple. Now, let's just go through the theory once. It's kind of complex, but I'm going to be explaining it with an example and then it'll become super clear. Let the number that we're going to be multiply is x, y, and z. That is where each one represents, where each variable represents their digit, right? So suppose we have 123, x is 1, y is 2, and z is 3, right? So basically it's the digits. And b over here is a variable, be the ones place of the number from 12 to 19. What this basically means is that 12, 13, 14, 15, so on till 19, b basically equals to their ones place. That is 2 in case of 12, 3 in case of 13, 4 in case of 14, 5 in case of 15, so on till 9 in case of 19. So basically, b can have values from 2 to 9. The arrangement of the digits, how we're going to be placing it. So this is basically the arrangement. And the product is going to be this. So let me just explain it once. First, we're going to write down the ones place of the number, 12 to 19. That is b. B, one below the other. We're going to be multiplying. This little star sign that you see is basically multiplying. Then we're going to be moving 0, first digit, second digit, third digit. This is for 3-digit numbers, right? So 0, x, that is the first digit, y, that is the second digit, z, that is the third digit. Then we're going to be adding plus signs, then x, the first digit, second digit, third digit, and 0, right? First digit, second digit, third digit, and 0. Whatever answer we're going to be getting, we're going to find it out. It's going to be D1, D2, D3, and D4, which we're going to be placing next to each other, carry forwarding wherever we require, and then we're going to find out the final answer. Now, with the variables, it obviously gets a little confusing. So let's see an example, 142 into 12. Now, let's keep in mind the formula that we have over here, which is this, okay? And let's understand what variables are which. B is the ones place of 12. Ones place of 12 is 2, right? So B is equals to 2. In 142, x, y, z is to be found. X is 1, y is 4, and z is 2, right? So we've written it down over here so that we can relate the formula and then write down the answer. Step 1, write down the ones digit. That is 2 in this case, 1 below the other, like this. Then multiply, sign ahead. Then 0. Then we're going to be starting off with the first. So for 142, the first digit is 1, then 4, then 2. This is the same order how we're going to be writing it over here. 1, 4, and 2. So it's basically writing down 142 vertically, right? And the plus signs, because that is the rule. Just look at the rule over here. We have the ones digit, then 0, 1, 2, 3, 4. 1 to 3 plus signs. And next, we're going to be writing 142 again. But this time, we're going to be writing 142 first and then 0 at the end. The difference is that in multiplication part, we place the 0 first. And the addition part, we place the 0 last. Okay, so let's see once again. We have first put 2, one below the other. Why 2? Because it's the ones digit of 12, right? Then multiplication, then 0. Then we're going to be writing the number digits one below the other. 142 is going to be 1, 4, 2 like this. So that's what we have kept, 1, 4, 2. Additions, plus, 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 plus. Then 142 once again over here. And this time 0 is lost. Okay? I hope that's clear. Now let's solve it. The first one, 2 into 0 is 0. 0 plus 1 is 1. A lot of you kind of do it wrong. You just impulsively add 2 plus 1, making it 3, but that's not how it works. 2 into 0 is 0, so be careful of that. The next step is 2 into 1, that is 2, plus 4, that is 6. In the next case, you have 2 into 4. 2 fours are 8, plus 2 is 10. In the next case, we have 2 into 2 plus 0. 2 into 2 is 4. 4 plus 0 is basically 4 as it is. That's it. Now we're going to be placing all of these digits that we have found one next to the other. 1, 6, 10, 4. Are we going to make that the final answer, 16104? Well, no, because one box can have only one digit, which is true here, here, and here. But over here, well, not so much, because 10 has two digits. What we're going to be doing is simply carry forward. So for 10, we're going to be retaining the ones digit, that is 0, and we're going to be carrying forward the 1, right? Yes. So the 1 from 10 is going to be carried forward to 6. So it's going to be 1 as it is. 6 is going to be added with 1. So 6 plus 1 is 7. Then from 10, we're going to be taking the ones digit 0, and then 4 as it is. So the final answer is 1704. Now, I know this might seem like a lengthy, whole thing, but when you practice it, it's going to be a lot faster than the conventional method that we use. Moving on to the next example, that is 431 into 15. Over here, for 15, the ones digit is 5. Therefore, B is 5. Okay, that as written here. For 431, X, Y, Z to be found. X is 4, Y is 3, and Z is 1. Now, this isn't really required to be always written, but to explain the concept to you, I'm just writing it down. Starting off, we're going to be writing B one below the other, 5, 5, 5, right? Then we're going to be multiplying it all by first 0, then 4, 3, 1. Okay, so that's what's going to come, 0, 4, 3, 1. Why? Because after multiplications, the multiplication signs, 0 is going to come first. Then we're going to write down 431 vertically. Vertically means in a straight standing line. So 4, 3, 1. That's how you write it.
Then we're going to place the plus symbols.
Then again, we're going to be writing 4, 3, 1 vertically and 0 at the end this time. 4, 3, 1, 0 at the end. Let's solve it. So 5 into 0 is 0. 0 plus 4 is 4 as it is. Then 5 into 4 is 20. 20 plus 3 is 23. 5 into 3 is 15. 15 plus 1 is 16. 5 into 1 is 5. 5 plus 0 is 5. Let's place them one next to other. Now, like I told you previously, one block can have one digit, which is true for this and this, but not so much for 23 and 16. So what we're going to do, we're going to carry forward. First, for 16, we are going to keep the 6, and the 1 is going to be carried forwarded. In the case of 23, the 3 is going to be kept, and the 2 is going to be carried forwarded. So how is that going to be? We have 5 as it is, 6 as it is. The 1 is carried forwarded to the 3. So 3 plus 1, that is 4, which is what we're going to be writing here. Then 2 is going to be carried forwarded to 4. So 4 plus 2 is 6, which is what we're going to be writing over here. So 6, 4, 6, 5 is what we're getting. And that is the answer. There you go. Thank you guys for watching this video. That was it for today. The practice one is going to be released very soon, so you can go and check that out later to clear more doubts. If you have any queries, you can ask that in the comment section. I hope this video was insightful and you all learned something new. Don't forget to subscribe to get the notifications for the next ones, like and share to show your support. Once again, thank you and bye-bye.